Good afternoon, class. We are looking at Exam 3 Review, Chapter 3, Differentiation Rules, Chapter 4, Applications of Differentiation, Application of Differentiation, which is going to cover from 3.9 to 3.11 and 4.1 to 4.5. Here's the first part, 3.9 related rates. So we're looking at the first part, 3.9 related rates. So for this exam, we're going to cover 3.9, 10, 11, then 4.1 to 4.5, and the last two for the next exam. For now, reminding everyone of various formulas we have seen for differentiation, such as the definition, power rule, trigonometric functions. We have the product rule, we have the quotient rule, we have the chain rule, we have exponentials, we have logarithmic, and now we have the trigonometric functions, their inverse trig functions. And these are a couple of definitions that remind us of what E stands for. 3.9 related rates. If we are pumping air into a balloon, both the volume and the radius of the balloon are increasing, and the rates of increase are related to each other. But it is much easier to measure directly the rate of increase of the volume than the rate of increase of the radius. So in a related rates problem, the idea is to compute the rate of change of one quantity in terms of the rate of change of another one, which may be more easily measured. So what is the procedure? Number one, find an equation that relates the two quantities. Number two, use the chain rule to differentiate both sides with respect to time. So therefore, in related rates problem, time is the only independent variable. And so dy dt is dy du, du dt. So the same type of question that was just mentioned, a spherical balloon is deflating, losing 8 cubic centimeters of air per minute. At the moment when the radius of the balloon is 20 centimeters, how fast is the radius decreasing? Number one, we are dealing with a spherical shape, and therefore we should know that the volume is 4/3 pi r cubed. This is the Leibniz's notation, dy dt is dy du du dt. So let's see what's given. Let's symbolize it mathematically, okay? So we should have this formula. We should know it. If the balloon is deflating and losing 8 cubic centimeters of air per minute, that means dv dt. That's the rate. dv dt is -8. Why? Because it's losing air, -8 cubic centimeters per minute. What are we interested in finding? At the moment when the radius is 20, when r is 20, what do we want to find? How fast is the radius decreasing? Or they might say changing. When you end up with a negative value, it means decreasing. Therefore, you're looking for dr dt when r is 20 centimeters. So this is translation of the question in symbolic form. So we want to differentiate this. We want dv dt. Now remember, 4/3 pi is just a number. So 4/3 pi times what? Now r cubed, 3r squared dr dt. So r cubed will give us 3r squared dr dt. Believe it or not, this is the only calculus part. These two cancel each other. We get 4 pi r squared dr dt. Replace the r with 20. Replace the dv dt with negative 8, include the sign. So minus 8 is 4 pi 20 squared dr dt. This is 400 times 4 makes it 1600 pi dr dt. And so we are going to divide both sides by 1600 pi. 8 goes away. Denominator is 200 pi. So minus 1 over 200 pi. And the units will always work accordingly. First of all, dr dt, the change in radius over change in time, centimeters per minute. Secondly, over here, if you put negative 8 cubic centimeters per minute, so you have it here, and then 4 pi 20 squared, that means centimeters squared, you see that the units will work. This is the exact answer. We want to keep it as pi. If you put it into a calculator where pi is 3.14159 and it continues indefinitely, we end up with this number with a bunch of decimals. So you want to be paying attention as to what they want. What I want, I always want the exact answer, okay? Because that's what we need in calculus. Could somebody read the question for us, please?
A 20-foot ladder leans against a building. The base of the ladder slips away at a rate of 2 feet a minute. Find the rate of change of the height of the ladder when the base is 12 feet from the building.
Perfect, thanks. So what do we do? Well, always draw the setting and then translate the question. So here's the setting, everybody. So here's the wall or the building. Here's the ladder. It's going this way. The process, it gives you this shape. Of course, this is a 90-degree angle. Everybody knows that. So this goes this way. This comes down. And this side is the ladder, which is fixed at 20 feet. So the hypotenuse, if you will, is fixed at 20 feet. As it moves this way, it creates a speed or rate of dx, dt equals 2 feet per minute. As it comes down, it creates the rate or speed of dy dt, and that's missing. So dx dt is known, dy dt is missing, this side is 20. You should know Pythagorean theorem says a squared plus b squared equals c squared. So that means x squared plus y squared equals 20 squared. And we want dy dt at a precise moment when the base is 12 feet from the building. That means x is 12 feet. So this is the translation of what we just see. All right. Now we are ready to move on. Of course, 20 squared is class 400, but it makes no difference when you differentiate it. So we are going to differentiate both sides of this with respect to t. So this gives you 2x dx dt. This gives you 2y dy dt, and this one, regardless of the number, gives you 0. And we are looking for dy dt. So we can plug in everything, but before we can plug in everything, we notice we have x, but we don't have the y value. So if we plug in 12 into this Pythagorean theorem, we can find the y when x is 12. You do the math, and you end up with 16 feet. You square that. I mean, I've already mentioned that. So this is 400. So you get y to be 16 feet. Now we have everything and we plug in 2 times 12 times 2, 2 times. This was missing. We found it. And so this is 2 times 2, 4 times 12. This is 48. This is 32. We are going to move the 48 and divide by 32. In other words, we are going to move this, making it minus 48 the other side, and we're going to divide by 32. Both of them are divisible by 16. We get negative 3 halves feet per minute. So I want to quickly remind you, as this gets away from the building, x is increasing. The x dt is positive. As this comes down, y is decreasing. That's why dy dt becomes negative, everybody. Dy dt is negative 3 halves feet per minute. The units work properly. The signs work properly. Okay, everybody. Could somebody read this for us? Actually, it's the same question. Let me just quickly mention it. It's the same question, and I want to go back to the previous page, and I want to explain something to you. When this comes down, this angle changes, also this angle, okay? We can discuss those as well. So, same situation, a 20-foot ladder leans against the building. The base of a ladder slips away at the rate of 2 feet per minute. Find the rate of change of the angle. But which one? The one between the ladder and the ground when the base is 12 feet. So we are repeating the same question. Okay, we just goes this way. Everything is the same. This is coming down. This is the angle that we are interested in between the ladder and the ground. That one is also changing. And so we know the x dt is 2 feet per minute. We are interested in finding d theta dt. So we write everything that we wrote in the previous one. We just add that d theta dt is missing. So if we go to the previous page, we had this, we had this, we had this, but now the thing we are interested in is d theta and dt. So whenever you want to solve a related rate problem, you have to relate the quantities. You have to find an equation that represents the quantities we are interested in d theta dt, where dx dt is known and x is known. So you might say, well, y is known from the previous page, but what if we made a mistake with our calculation? So you always use the ones that are already given to you. So you have no doubts. So we have no doubts dx dt is 2 feet per minute. We have no doubts the base is at 12 feet. Okay. And so with that being the case, I'm going to remind you of the concept of sine and cosine. Sine of this angle is the opposite over the hypotenuse, okay? And cosine is the adjacent over the hypotenuse, okay? Of course, this means y over 20, and this means x over 20. So we are going to use this one. This is x over 20. This is y over 20. Y, or we can even use this because we already have the information about what. But it's better to use what we know. So we are going to use cosine theta is x over 20. And I'm going to rewrite it in case anybody can't see that this means 1 over 20 times x. So 1 over 20 is simply just a number. Okay, so if I want to differentiate, I'm going to differentiate both sides with respect to t. Cosine, as you know, becomes negative sine. Negative sine of what? So negative sine of the same thing, theta. And we are differentiating with respect to t. Therefore, d theta dt, the right side is 1 over 20 times. Now, x gives us the xt. Now we can plug in everything that we have. If you look at this, you see that you have the xdt. You go here, so far so good, but you don't have the sine minus, what is sine? Y over 20. And we had calculated the y in the previous page as 16. So we can replace the sine with y, which is 16 over 20. So negative 16 over 20, d theta dt remains. 1 over 20 remains, 2 remains. Now, one easy way to solve this fraction, notice they have the same denominator, everybody, so I can just get rid of the 20. So the left side is negative 16 d theta dt, and the right side is just number 2. So I want to make sure that we understand. So left side is negative 16 d theta dt, and the right side is 2. So divide by negative 16. And you get negative 1 over 8. And the units are the units of the numerator over the units of the denominator. The units of the numerator is always in radians when it comes to angles per whatever units of time. The units of time were minutes. Now, the only time it's not radians when it is mentioned, it's not. Otherwise, we must use radians. Could somebody read this question, please?
Falling sand is forming a cone-shaped pile. The volume of the cone is increasing at a rate of 54 pi inches cubed per minute. The height of the cone is twice the radius of the base. Find the rate at which the radius changes when the radius is 6 inches.
Excellent. Thank you so much. All right. So first and foremost, what is a cone? Looks like that. The volume of a cone, 1/3 pi r squared h. So we should know the shape, and we should know this formula. The volume is 1/3 pi r squared h. We go back and reread the question. The volume of a cone is increasing at the rate of 54 pi cubic inches per minute. So this is the rate, that is dv dt. dv dt is this much. The height is twice the radius. H equals 2r. H equals 2r. Find the rate at which the radius changes. Find dr dt. When? At the moment that r is 6 inches. So this is the translation of the entire question, everybody. So if we can go from here to the setting, and this, practically we're done. This is the way you solve related rates. Remember, those are word problems. So if you were to differentiate this just the way it's given, and you won't, you need to understand there are two variables, and you need to do the product rule. However, since we want dr dt, we want to solve for R, so that we want to have just R, nothing else, and therefore we're going to replace the H with 2R. If the question was asking for dH dt, then you would replace the R. And how would you replace it? R is H over 2. So right now, H equals 2R. So H is replaced by 2R, and we get 2/3 power cube. That's the first thing, elementary algebra. Now we are going to differentiate this with respect to t. So this is dv dt. The right side, 2/3 pi is just the number. So 2/3 pi times what? R cubed 3r squared dr dt. 3r squared dr dt. Simplification will give us 2 pi r squared dr dt. So just plug in. What is dv dt? See, this really is a lifesaver. What is dv dt? We wrote it, 54 pi. 2 pi r squared dr dt. What is r? 6 inches. Missing is dr dt. And so this is 36 times 2 pi makes it 72 pi. We are going to divide both sides by 72 pi in order to reach dr dt. 54 pi divided by 72 pi. Obviously, these two cancel each other. Both of them are divisible by 18. We get 3/4 of an inch per minute. Again, the units must work. dr dt, the change in radius over the change in time, and it works. Again, you can write 54 pi cubic inches per minute, and instead of 6, write 6 inches to the second power. You see that it does work. Could somebody read this, please? Again, everybody can participate. I truly appreciate it. Go ahead. Somebody read this for us, please.
Can you hear me?
Yes, go ahead. Go ahead, Chair.
At noon, ship A is 150 kilometers west of ship B. Ship A is sailing east at 35 kilometers per hour, and ship B is sailing north at 25 kilometers per hour. How fast is the distance between the ships changing at 4 p.m.?
Excellent. This is what I mean by setting up and drawing the setting to understand the question. Okay, so let's see how we do that from A to Z. At noon, let A sub 0 be the position of ship A, and B0 be the position of ship B. Therefore, we have this distance of 150 kilometers. So A sub 0 moving this way towards east, B sub 0 moving this way towards north. This is to begin with. We have a distance of 150 kilometers. That is exactly at noon. A moves east at 35 kilometers per hour. Let x be the distance traveled by A. So A moves so much, x amount. Similarly, B, this is of course, again, x is distance traveled by A at time t. Similarly, B moves north at 25 kilometers per hour. Let y be distance traveled by B. So this is the distance by ship A. This is the distance by ship B at any given time. dx dt is 35. Please understand the rate or speed is the same thing. So going this way generates the speed dx dt is 35 because it's given, right? 35 kilometers per hour. Whereas going up north, dy dt is given at 25 kilometers per hour. So if we have gone this much, what is left? So the distance left to cover the entire 150 kilometers is 150 minus that. So this distance is 150 minus x. So if you look at these three drawings, it gives us the whole situation from A to Z. So here's the question. dx dt is given, dy dt is given, okay? We want to know at 4 p.m., meaning what? At t equals 4, everybody, from at noon and then at 4. From the time we left up to 4 o'clock, t equals 4, what are we interested in? How fast is the distance between the ship changing? So this is x, this is y, this is d. I like to call it z. So dz dt. So d or z. So dx dt is 35 kilometers per hour. dy dt is 25 kilometers per hour. T equals 4. Why is t equal to 4? From noon to 4 p.m. We want, and I don't want to use dt. So I'm going to call this z. Okay? dz. And we are going to start with formulas and take it from there. So what formula are we using? Obviously, we are going to use Pythagorean theorem, a squared plus b squared equals c squared. Okay. So this squared plus this squared is this squared. So 150 minus x quantity squared plus y quantity squared is equal to z squared. That's it. You are going to differentiate, and you're going to differentiate with respect to t or time. Again, I hope you realize the hardest part is going through this process, writing the given, and this coming up with this equation. But coming up with this equation, we have to have a justification. I can't come up with this equation without justifying my steps. Okay? So even if I come up with the equation without having those steps, it basically makes no sense. Now, we are going to differentiate with respect to t. And I hope you realize this is 2 times 150 minus x to the power of 1 times negative dx dt. Remember, the derivative of x is dx dt now. It's not 1. Y squared, 2y dy dt. Z squared, 2z dz dt. So please understand, this is very straightforward. Again, I want to make sure we understand this one. 2 sits in front. The same thing to the power of 1. The derivative of the inside is minus dx dt. So this results in this. I can solve for dz dt, or I can plug in everything that I need to and calculate the dz dt. So let's do that. In order to plug in, I need to know x and y at 4 p.m. So when we go to 4 p.m., t equals 4. So this distance, everybody, is 4 times whatever the speed is. This distance is 4 times whatever the speed is. Okay, so for x, we use the x dt, so 4 times 35. And for y, we use the y dt 4 times 25. So x is 140 kilometers and y is 100 kilometers. Okay, simply because of d equals rt, right? Distance equals rate times time, because that's the average speed. So let's replace the x with 140, replace the y with 100. Okay, dx dt, so minus dx dt minus 35, dy dt 25, 2 times z. Now, I also need to calculate the z. So I go back to this formula, to this one, and I see I have x, I have y, I can calculate z. So I'm going to put x and y into this. So 150 minus 140 squared plus 100 squared equals z squared. Needless to say, this is 10, you square it, you get 100. 100 squared is 10,000. They add up to 10,100. Z is precisely the square root of 10,100. Okay, because I want to make sure that we understand what happened here. This, everybody, is 100. And this is 10,000. So 10,100, you take it. So we are going to replace everything that we have. That's the left side. 2 times 150 minus 140 minus dx dt minus 35 plus 2 times 100, because y is 100 and the yd is 25. The right side is 2 times this number times dz dt. And all you have to do is simplify the left side and divide by 2 times square root of 10,100. You have the answer. Okay, just for the sake of argument, and this is very straightforward. This is 10. So we have minus 700 plus 2 times 25 is 50 times 100 is 5,000, and we add them up. The left side is minus 700 plus 5,000, 4,300. So we divide the left side by 2 square root of 10,100. Let me just actually show you what I have here also by cleaning up the mess. So minus 350 plus 2,500 and times 2, of course, okay, when you divide it by 2. So this, when you divide it by 2, because there is a common factor of 2 here, okay. So 2,150 divided by square root of 10,100, and now using a calculator with, I don't know, however many decimals they ask you, you come up with 21.4 kilometers per hour. All right, so again, you want to be careful with the number of decimals. Okay, whatever they ask you, you're just going to follow that. 21.4 kilometers per hour. Therefore, as A goes this way, B goes this way. They are getting closer at a rate of 21.4 kilometers per hour. That's the easy. Could somebody read this one, please?
A spotlight on the ground shines on a wall 12 meters away. If a man 2 meters tall walks from the spotlight toward the building at a speed of 1.6 miles per second, how fast is the length of his shadow on the building decreasing when he is 4 meters from the building?
Excellent. And by the way, they may not use the word decreasing. Changing they may use. If it's negative, it represents decreasing. If it's positive, it represents increasing. So again, let's go through the setup. So spotlight, you're moving towards the wall. This one, this is where the spotlight is. This is where the wall is. And it has a distance of 12 meters. So from here to here is 12 meters. So a man moves this way. That is 2 meters tall. So walks away from the spotlight and towards the building here. There is some sort of a building. And it looks like that. Here's the man. Here's the light. Here's the wall. And the man is going this way. The man is 2 meters long. And the man has covered X amount. Okay. He's 2 meters tall. And the wall, whatever the shadow is Y amount. Okay. So if this is X amount, then the distance to the wall is whatever is left of the total. The total was 12. So if this is X, this is 12 minus X. For example, if this is 5, this is 7. If this is 8, this is 4. This is 2, this is 10. That's the concept. When the man covers X feet, its speed is dx dt. So dx dt is what? 1.6 meters per second. 1.6 meters per second. That's the speed. What are we looking for? How fast is the length of his shadow? The length of his shadow is considered y. That means dy dt, because we want the speed or rate. How fast is the length of his shadow on the building changing? Think about it, changing. So that means the moment you see how fast it's referring to the rate, that means dy dt. At what point? When he is 4 meters from the building, when 12 minus x is 4, which means x is 8. Okay, so first, dx dt is 1.6 meters per second. dy dt is of interest to us. At the moment when 4 meters from the building, 12 minus x is 4. So this is the drawing. This is the translation of the question. Let's move on. To do so, first and foremost, just recognize 12 minus x is 4 means x must be 8. That's the first thing we should recognize. Then we notice the concept of similar figures. That means the small one and the large one are similar. And I'm going to remind you of similar figures. Similar figures, corresponding angles are identical or equal, and corresponding sides are in proportion. This is the simplest definition I can remind you of. So if you look at this, we have two triangles. Look at the smaller one. Let me shade it. This is the smaller one. And the big one. They are similar. Why is it? This one is in common. This angle are identical. This is 90 degrees, so is this one. And as long as two angles are equal, the third one must be equal, and therefore they are similar. Okay. Or you can say these two lines are parallel, and that pretty much does it. So if they are similar, corresponding sides are in proportion. So what are the corresponding sides? Well, I can say if I choose y from the larger triangle, then I have to choose 12 from the larger one, right? If I go with the larger one. Y from the larger one, 12 from the larger one. Why am I using 12? Because it's known, completely known. Then for the smaller one, corresponding to y would be 2, corresponding to 12 would be x. So I hope you see that the ratio of y to 12 is the same as ratio of 2 to x. Practically, I'm done. As long as I know which equation to use, the rest becomes fairly simple. And I hope you realize that I can multiply this one by 12, right? Cross product, I get 24 over x, or 24 x to the power minus 1. I'm assuming this is elementary algebra. Nobody has any problem with that. To differentiate this is 24 times negative 1 x to the power of negative 2. Let me just write it down. So if I want dy dt, okay, first is 24 times negative 1 times x to the power of minus 1 or minus 2, and then times what? dx dt. Of course, 24 times negative 1 times x to the power minus 2, we change it to negative 24 over x squared. Now we are in business. We just plug in the numbers that we have, which means I'm going to replace the x with 8, dx dt with 1.6. Do the math, we end up with negative 0.6 meters per second. You may recognize, class, you can say this is divisible by 8, becomes 3, and this becomes 8, and 1.6 divided by 8 becomes 0.2. The product of negative 3 and 0.2 is negative 0.6 meters per second. It's really pretty straightforward, everybody, okay? So the length of this his shadow is decreasing at the rate of 0.6 meters per second, because the question may be asking, okay, how is it changing? And that's the case, class, okay? It's decreasing. Why is it decreasing? Negative sign. A cylindrical tank with radius 10 meters is being filled with water at a rate of 7 cubic meters per minute. How fast is the height of the water increasing? Draw a diagram, include units. Always draw a diagram, class. So this is what we have. A cylindrical shape. The radius is fixed at 10 meters. You can call it capital or 10 meters. The radius is not changing. And we should know the volume is pi r squared h. We are filling it up at a rate of 7 cubic meters per minute. That means dV dt. This means dV dt is 7 cubic meters per minute. How fast is the height, dH dt, changing? So we write down V is pi r squared h. That's a piece of information from before, from algebra, geometry, you name it. dV dt is given as 7 cubic meters per minute. And R is fixed at 10 meters. We want to find dH dt. Well, since R is fixed, you can replace it or you can keep it as fixed. So just, if you want to differentiate, this is pi r squared times h gives you dH dt. H results in dH dt. And now replace whatever you have. What do you have? We have dV dt, we have R, okay. And so this is 100. We're going to divide both sides by 100 pi, and that gives you the exact answer. 7 over 100 pi meters per minute. The units are the units of the numerator over the units of the denominator, change in height over change in time. Or right here, class, before we differentiate, we can replace this and we get 100. So V is 100 pi h. If you replace this R, because 10 is fixed, get 100 pi. And now if you differentiate, dV dt is 100 pi times dH dt, which is exactly what we have here. Okay, same thing that we have here. All right. Again, pretty simple and straightforward. If the minute hand of a clock has length r in centimeters, whatever the units are, find the rate at which it sweeps out area as a function of theta. They're referring to this concept, class. Okay, this is the theta, and I want you to remember that the area of a sector is half of r squared theta, and S, the arc length, is r theta, and this is theta, everybody. Okay, so you should remember all of that. So we are looking at a circle, right, a clock. We are assuming here's the minute hand with the length of r, and it goes around the circle. As far as the area is concerned, area is half of r squared theta. As far as the arc length, S equals r theta. Again, I'm just reminding you of that, and you need just the area because the rate at which it sweeps out the area, you don't need this one. You just need the area, everybody. Let me just. So this is the area. And so you need that one. But I wanted to remind you of both. So you know which one you're dealing with. I wanted to remind you of both from geometry, everybody. Okay. So if the area is half of r squared theta, we are interested in finding the ADT where R is fixed, whatever it is, R is fixed. The length is not changing. It may not be given to us, but it doesn't matter. It's fixed. So to find the ADT, 1/2 R squared is fixed times d theta dt. D theta dt, everybody. Half of R squared times d theta dt. And believe it or not, that's it. But what does it mean? I want to make sure you understand that with a simple example. So the ADT is simply 1/2 R squared times d theta dt. So for example, 1 hour means 360 degrees means 2 pi radians. We go with radians. So d theta dt for 1 hour, we're going to go with, we're going to replace it with 2 pi, because in 1 hour, the angle we cover is 2 pi radians, right? In 1 hour. Minute hand completely covers a complete revolution of 360 degrees or 2 pi. So in 1 hour, the minute hand covers 360 degrees or 2 pi. So it's 2 pi that is going to replace the theta dt. And so these two cancels out these two. So it's pi r squared. Pi r squared what? Since it's r squared, centimeter squared, and this is what? Per hour. This is 2 pi radians per hour. 2 pi radians per hour. For example, if we are interested in 1 day or 24 hours, so the minute hand covers this circle how many times? 24 times. Each time covers 2 pi radians. Therefore, instead of 2 pi here, you have to put 24 times 2 pi. And whatever the answer is, would be centimeter squared per day. Per day. And that's extremely important to understand, everybody. Okay. I go to, okay, per day. Okay. So just this one is going to replace the 2 pi. And we want to be very careful of that. Okay. Can somebody read this question for us, please?
A streetlight is mounted at the top of a 15-foot pole. A man 6 foot tall walks away from the pole with a speed of 5 feet per second along a straight path. How fast is the tip of the shadow moving when he is 40 feet from the pole?
Excellent. Again, let's set it up so we can figure out what needs to be done. Let's set up the drawing and everything else. So street light at top of 15-foot pole. A man 6 feet tall walks away from it. The speed of the man is dx dt, or 5 feet per second. along a straight path. The tip of the shadow is also moving. We want to know how fast the tip of his shadow moving when he is 40 feet from the pole. So let's see what we should do, everybody. So tip of the man's shadow is here. When the man covers X feet, its shadow covers more, covers Y feet. Again, X and Y, we are making up variables. So when the man covers X amount, the tip of its shadow covers Y. We know that the man is moving at 5 feet per second, so dx dt is 5 feet per second. We want to know how fast the tip of the shadow, dy dt, we want to know what it is. At what point? When the man is 40 feet from the pole, when x is 40. So this is the drawing. Given dx dt is 5 feet per second, what is dy dt when x is 40? This is the explanation of the whole situation. These two basically give us everything we need. So let's set up this drawing down here as follows. This is 15, 6. This is X amount, which we don't have. This is Y amount, which we don't have. So you can see that we can use similar figures. In other words, small and large triangle. So this one versus the entire one. Again, why are they similar? Two different ways of approaching it. This is a common angle. This is 90 degrees. This is 90 degrees. These two must be the same identical angles, so that they must be similar, or you can say these two are parallel. Okay, if two sides are parallel, that's the case. These two are parallel, and these two are also, the small one and the big one, parallel. And so if we want to look at that, let me show you. The shaded one is the smaller one. This is the smaller. So I want to try this slightly different, because I want to show you that the similar figures, you have different ways of approaching it. You can pick one from the small one from the large one. So if I pick this side from the small one over this side from the large one, then I have to pick this side from the small one, and the large one is y. So it's 6 over 15, and this one which is what?
Y minus X.
Perfect, 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 perfect. So y minus x over y. And that's it. So we have the drawing, we have the given, we can make up this equation practically. We are done. The hardest part is coming up with that equation. So the cross product will do the job. 15 times y minus x equals 6y. And so we have 15y minus 15x equals 6y. As you can see, I can move things around. Moving this one this way becomes negative, and this one this way becomes positive. So 9y equals 15x. I'm going to solve for y, and I get 15 over 9, or 5/3 x. Now we are ready to differentiate. dy dt is 5/3 dx dt. And dx dt is known to be 5 feet per second. If you plug it in, 5 thirds times 5 becomes 25 thirds feet per second. 25 feet per second.